Good morning, guys. Let's hope this works this time. I'm trying a different way of doing it, and we're going to talk about Lewis structures. And I want to thank you for the kind words last night. I definitely needed them. Hopefully, technology will not defeat me this morning. Let's pray this is true. So, we're going to talk about Lewis structures. And Lewis structures are a way of us visualizing how a molecule or an ion would bond. And we're going to use a method called NASL, nasal. And it is pretty straightforward, but the first thing we need to know before we get into it is where are valence electrons and how do I figure that out? It is so simple. I'm going to get out my periodic table. So here it is. We're not worried about the noble gases, but we're going to start over here with group 1 has 1 valence electron. Group 2 has 2 valence electrons. We're not going to do any in the D block, so you can skip all of those. Group 3 has 3 valence electrons. Group 4 has 4. I think we get the idea. 5, 6, 7. These all have 8, except for helium would just have 2. But again, noble gases we're not concerned with, just like we're not concerned with the D or the F block, just S and P. So you just count across, and that'll tell you your valence electrons. So the second thing we need to know is that there are some exceptions to the octet rule. So first off, the octet rule states that atoms want to either share or have for themselves 8 electrons. But there are some exceptions. And those exceptions are group 1, group 2, and group 3. These are like hydrogen. Group 1 only makes 1 bond and it shares 2 electrons. So this is going to be our bonds. This is going to be our electrons. Group 2 makes, you figured it out, 2 bonds, which means 4 electrons. Group 3 makes 3 bonds, which is 6 electrons. Everybody else is going to have 8. Okay, so far so good? Hopefully. If you start having issues, you should write down your questions so that we can go over them together in class. Hopefully we'll get a chance to go over this in class today. I'm going to put this here. I'm not going to read it to you, but I want you to pause the video so that you can read this and then come back, because I don't want to take time in the video to read to you. You're smart enough to read for yourself. So pause now. Okay, now that you've read it, you don't understand it, and that's fine. That's what I'm here for. So we're going to go through an example, CF4. So the first thing it says is to select a reasonable skeletal structure. And I'm going to tell you this, the unique atom is always in the center. So carbon's going to be in the middle, and the fluorines are going to be on the 4 different sides. So I've done the first step. Second step is to calculate how many electrons you need. So need means that everybody here is not an exception to the octet rule, so they're all going to want 8 electrons. How many atoms do I have? 1, 2, 3, 4, 5. I have 5 atoms that need 8 electrons, so that's 40. So my need is 40. Next, calculate available. This is the sum of the valence electrons. So back to our periodic table. And we find that if we count over for carbon, 1, 2, 3, 4. If we count over for fluorine, 1, 2, 3, 4, 5, 6, 7. So carbon has 4 valence electrons, and we have 1 of those, and we have 4 fluorine atoms that have 7 electrons. And so that's going to be 28 plus 4 is 32 electrons. So this is going to be 32. Okay. So, calculate the available. We just did that. If it has a charge, if it's negative, you're going to add in electrons equal to that charge. If it's positive, you're going to subtract out electrons equal to that charge. Calculate the shared. This is the difference between N minus A. So N minus A is going to be 8. Now, if we want to figure out how many bonds that means, because each line is worth 2 electrons, we would take S and divide it by 2, which is going to be 8 over 2, which is going to equal 4 bonds. So we have 4 bonds in our structure, and this calculation is telling me that's what I need, so I don't need any extra bonds. I'll do another example where that's not true. So divide S by 2 to obtain the number of bonds. Calculate lone pairs. So lone pairs is calculated by A minus S. So here's A, here's S. So 32 minus 8 equals 24. So that means I have 24 dots to put on my structure to get all atoms up to 8. Carbon right now is up to 8, so I'm not going to put any dots on carbon, but I am going to put dots on fluorine. And I've got 4 fluorines, so I would divide 24 by 4, and that gives me 6 dots per atom. So I'll put 2 dots on each of the sides that doesn't have a bond. So I'll put them here, here, there, 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 there. This is so exciting. So I put in my 6 dots per atom, and that gave me 24 dots. So, and everything is good. We're now going to check that we have the total number of dots used, or that the total number of electrons is equal to A, and A is 32. So I find one spot on here and I start counting, and I go around clockwise. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. And I have 32, so it works out perfectly. Let's do another example. Let's do CO2. So I'm going to move this off to the side. You might want to have it pulled up so that you can look at it as well. I would maybe eventually print it out and have it in my composition notebook. So let's do CO2. And the first step is to make a structure. So carbon's unique, it's going to go in the center. I'm going to attach to the 2 oxygens. Next, I need to figure out how many I need. So need is just how many atoms. Are there any exceptions? Nope. We're not in groups 1, 2, or 3. So each one of these needs 8. There's 3 of them, so 3 times 8 is 24. That's how many I need. How many are available? Going back to my periodic table. We're going to count over. 1, 2, 3, 4 for carbon. 1, 2, 3, 4, 5, 6 for oxygen. So I need to figure out how many are available. So for carbon, I have 1 carbon. It has 4 electrons. I have 2 oxygens with 6 valence electrons. That's 12, 16. So available 16 electrons. Now, shared is going to equal N minus A, which is 24 minus 16, and that's 8. To figure out the number of bonds, it's going to be shared divided by 2. So that's going to be 8 divided by 2. That's 4 bonds. Right now, I don't have 4 bonds. I only have 2 bonds. So that means I need another bond for each oxygen to carbon. That gives me my 4 bonds. 1, 2, 3, 4. So now I've got my shared taken care of. Now my lone pair electrons, or my lone electrons. Lone electrons is A minus S. So how many do I have available? How many have I already shared? Will tell me how many are left over for lone pairs. So 16 minus 8 is 8. Carbon already has 8 electrons, so it's not going to receive any dots. The oxygen atoms will each receive dots. I have 2 oxygen atoms, so this time I'm going to divide by 2 to see how many dots to put on each atom. And that's going to be 4. So I'm going to put 2 here, 2 here, 2 here, and 2 here. The last step is to check that we used the right number of electrons, that we've used exactly 16. So starting right here, 2, 4, 6, 8, 10, 12, 14, 16. Yep, I used 16 electrons, so this will be a good Lewis structure. I'm going to do additional problems in class just so that you can see them, and hopefully this will help you. Please let me know if you have any issues or you need some additional help. Thanks. Bye.